Let's start by passing out homework. Jimmy Flood. Hoorah. John Caldwell. Michael DeBach. Jesus Antonio Rodriguez. And you know what's really annoying? Is about the time I've actually learned names and associated them with faces, the semester will be over and I'll have to start all over. Tyler Koshiwe. Val Peterson. Jimmy Flood. Make sure I'm not giving you. Deja McClellan. Travis Black. John Caldwell again. Jesus Rodriguez again. Jacob Childers. Derek Heineman. Kyle Kohler. Excuse me. Jared R. or 2. Jesse Martin. You're welcome. You bet. Jacob Hoffman. And another Michael DeBach. Christopher Macklin. Jacob Hoffman. And Jesse Martin. I get it. Jared Robertson. Kyle Kohler. Derek Heineman. Anthony Lee. Here, while I'm doing this, I'll sign in and pass that around. Anthony Lee. Jacob Childers. Carlos Aguilar. Yeah. Jory Owens. Travis Black. Deja McClellan. Jimmy Flood. Jesus Rodriguez. Tyler Koshiwe. I think I have one here for you too. Yeah, right there on top. Brandon Simpson. Jeremy Reetcook. Am I at least pronouncing that right? Reitkerk. Jacob Sanchez. Kyle Kohler. Jess Martin. Michael DeBach. Megan Walker. You're not Megan Walker. I know you're not Deja McClellan. And I know you're not Travis Black. Wait, where did he go? There he is. Carter DuBarry. Chris Macklin. Carter DuBarry. And Carter DuBarry. And Carter DuBarry. I'm sensing a theme here. Matt Letney. Matt Letney. Jacob Sanchez. Sanchez. And Tyler Koshue and Tyler Koshue. All right. Okay. So we got an exam this week. Got it scheduled for Thursday, and today is scheduled for review. So I guess the best way to do a review is to start by asking if there are any questions about the work that we've been doing since the last exam.
38 on 142.
38 on page 142. Aha! Yeah, this is one of your homework problems. And it says, sine and cosine are given. Find the exact value of each of the four remaining trig functions. So we got sine of theta is equal to minus square root of 5 over 5. And cosine is 4 over 5. Oh, sorry, I skipped up one. Yeah, he said 38. Cosine is minus 2 times the square root of 5. Minus 2 times the square root of 5 over 5. Or minus 2 over the square root of 5. All right. So now we want the tangent of theta, the cosecant of theta, the secant of theta and the cotangent of theta. What's the first thing we want to know? Well, actually, we actually already have everything we need to know. What's the tangent? It's the sine divided by cosine. So we've got square root of 5 over 5 divided by 2 times the square root of 5, negative, over 5, which is the same thing as negative square root of 5 over 5 times negative 5 divided by 2 times the square root of 5, which is, these cancel, a negative times a negative is a positive, and it's 1 over 2, it's plus a half. What's cosecant? Just it's the reciprocal of, the cosecant is the reciprocal of sine. Well, sine is negative 1 over the square root of 5, or negative 5 square root of 5 over 5. So the cosecant is negative 5 over the square root of 5, or negative square root of 5. What's the secant? Just the definition of the secant. What is it? Reciprocal of cosine. So it's negative 5 over 2 times the square root of 5, or negative square root of 5 over 2. And the cotangent is the reciprocal of the tangent. So it's plus 2. That's the whole problem, 38. Just looking at the information we have, what quadrant is theta in? Cosine is negative, sine is negative. It's in 3. What else can we know about this? Without anybody looking at their calculators, does this lie on the unit circle? Or does it lie on a circle with a radius r greater or less than 1? How would you determine that? What's your name? Megan? Megan Walker. Somebody think of how you would determine whether or not this is on the unit circle. And who else came in after we started? Names? Okay. No Carter Dewberry? No Deja McClellan? Derek Heineman? Kyle Kohler? Oh, another Derek Heineman. Anthony Lee. Jory Owens. Deja McClellan. I know I got a couple of Megan Walkers in here. Jeremy Wrightkirk. Jacob Sanchez, Kyle Kohler again. Megan Walker. Oh. Carter Dewberry. Matt Letney. Jacob Sanchez. All right. Anybody come up with an answer? How do we determine whether or not the point how would we determine if we're on the unit circle here? What's 1 over the square root of 5? Negative 1 over the square root of 5 squared. 1/5 plus 2 over the square root of 5. 4/5 equals 5/5. 1. Does that tell us if we're on the unit circle? No, not really. All that tells us, if you'll remember, this in fact does give us a point on the unit circle. This sine and cosine does. But that's because it's been reduced to sine and cosine. What if you were given a point not on the unit circle? That's a circle of radius 1. What if you were given a point out here at 5, 6 and asked what's sine and cosine and what are the 6 trigonometric functions of that angle between a ray that passes through that point not on the unit circle? We know if we had the point on the unit circle, well then the x and y coordinates of that point are the sine and cosine of that angle. But what if the point is not on the unit circle? All we're told, suppose all you were told is that you have a point, you have a ray from standard position that starts at the origin and passes through a point. What did I use, 5, 6? Is that point on the unit circle? And how would you find the 6 trigonometric functions? Well, now you'd use Pythagorean's theorem and go 5 squared plus 6 squared is 25 plus 36. And I'm getting into arithmetic now. So let's see, that's 11, 61. Somebody check my arithmetic, is that right? Okay. And so R, that wouldn't be there. R would be the square root of 61. Pythagorean's theorem gives you R squared. So the square root of 61 is not 1. And we know that because 1 squared is still 1. So whatever squared equals 61 is not 1. It's not on the unit circle. Now how do we find if it were on the unit circle, then the coordinates of the point are the sine and cosine. Or cosine and sine, actually, in order. But what about this point? Now how do we find the sine and the cosine of this point? Say again? Y over radius. Sine theta is y over radius. Or in this case, 6 over the square root of 61. Cosine is 5 over the square root of 61. What's tangent? Y over x, which is 6/5. Cosecant, square root of 61 over 6. Secant, reciprocal of cosine, square root of 61 over 5, and cotangent, 5/6, reciprocal of the tangent. Remember, I scheduled today for reviewing for the test. So there might be a reason that I point out to you that you want to know how to do this. Okay? Say again? Okay. Reminder, you can use a calculator, but it cannot be a graphing calculator. It has to be a standard scientific calculator. And you can only use it, you cannot use it on the problems that say don't use a calculator. Find an exact value, and frankly, if you've been studying, you don't need a calculator. How many times have I used a calculator? Only once did I need one, and that was just to do some addition. Okay. I can do math. It's the arithmetic that trips me up. And there is a difference. Calculate, and I'm going to hit on this point again. I want to emphasize it again. It's important. This is stuff that you have to learn because of the field that you have chosen as your major field of study. The profession that you have chosen that you want to go into requires you to know this stuff. You're going to need to be able to do it. So you need to use the calculator to do the arithmetic. Use the calculator to do the computation. But use your brain to do the math. I think I've shown you, I did show you all the other day how, just pushing the inverse tangent to find an angle can get you in trouble if you're in the wrong quadrant. The algorithm in your calculator is going to return an angle from a tangent function between minus pi over 2 and pi over 2. Between minus 90 degrees and plus 90 degrees. So if you're at 95 degrees, then it's going to end up giving you an angle of minus 85 degrees. 180 degrees out of in the wrong direction. Who remembers the phrase standard position? What does that mean? It means everything comes from the origin, and the positive angles are swept out in what direction? Counterclockwise. If you have a negative angle, then that is swept out clockwise. If you have, change colors, minus pi over 2, pi over 4, is the same as plus 7 pi over 4, if I did the arithmetic correct. If you're given, I'm going to see if I can trip you up now. So everybody, giving you fair warning, this is a trick question. And it's one you can use your calculator for. What is the sine of 45? Say again? The sine of 45 is pi over 4? Yes, what is sine of pi over 4? So you're getting square root of 2 over 2. Or 1 over the square root of 2. Is that what you're getting? Is anyone getting the right answer?
I got 0.850904.
How did you get that? What mode are you in?
Radian.
You're in radians. That's the difference. I did not ask for the sine of 45 degrees. I asked for the sine of 45. When you see a number with nothing else, that by definition, by default, means radians. Now, I'm not going to do that on the test to try and trip you up, because that's not the point of teaching you trigonometry. It's not to see if I can trick you. But it is the kind of thing that can sneak up on you and bite you when you're trying to do this for real for a paycheck. When you see the little circle superscripted, that means 15 degrees. How would you convert 15 degrees into radians? Say again? You've got 15 degrees. What is that in radians? Exactly. Because there are pi radians is equal to 180 degrees. This is how conversions work. As long as this and this are equal, then if you divide this by this, what's the ratio? No, the ratio is 1. If this and this are equal, then this divided by this is 1. So you can multiply anything by 1 and you still get the same amount, the same value. What's changed are the units that it's in. So if there are pi radians in 180 degrees, the degrees cancel and you're left with radians. If you're given 15 radians and you want to convert that into degrees, how would you do that? You're in radians, and you want to convert to degrees, so you multiply by 180 degrees for every pi radians. Now the radians cancel and you're left with degrees. How would you convert 5 pi over 4 radians, convert that into degrees? Pi's cancel, you get 5 times 180 divided by 4. What is that in a number? Somebody do the arithmetic. Give me a number. It's actually an integer, 120. Please tell me it doesn't come out to an integer. It's exactly 225 degrees. Well, that bit me. Okay, well, that's right. It's 225 degrees. And what if it was, let's pretend like I didn't just ruin the example, and let's say it came out to 236.871954 degrees. How do we convert that into degrees, minutes, and seconds? That equals 236 degrees plus 0.871954 degrees times 60 minutes per degree, which is, somebody do the arithmetic, please. 62.31725. 52. Okay, somebody make up my mind. 52.31724 minutes, which is equal to 52 minutes plus 0.3172 minutes times 60 seconds per minute. .0344 seconds. So that converted into degrees, minutes, and seconds is 236 degrees, 52 minutes, and 19.0344 seconds. What if we were going backwards? What if you were given this many degrees, minutes, and seconds and told to convert it into radians? We go backwards. 236 degrees plus 52 minutes plus 19.0344 times 1 minute per 60 seconds. You back it all the way back until you end up with this. And then you multiply that times pi radians per 180 degrees. Do we need to go through the process and to see how it's done, or has everybody got that? Is everyone familiar with the properties of the functions? What are the domains and the ranges of all of the trig functions? What's the domain of sine? All real numbers. Or you could just write out all real numbers. Or in set notation, use the curved parentheses to indicate that the endpoints are not inclusive. It goes from minus infinity to plus infinity. Remember the set notation, the curved braces means that the endpoints, in this case plus and minus infinity, are not inclusive. You can never get to infinity, but you can get as arbitrarily close to it as you choose, if you've got a big enough computer with enough decimal places. What is the range of the sine function? Yeah. In set notation, minus 1 to 1, using square brackets instead of the curved parenthesis to indicate that the endpoints are included. That you actually can get to minus 1 and to plus 1, or any point in between. What about for cosine? Domain? Same thing. And the range is the same. Now we get to the tricky ones. What is the domain of tangent? An element of all real numbers except k pi over 2 such that k is odd. Okay. And the range? Plus or minus infinity? Non-inclusive. You'll never include infinity because you can't get there. Anyone remember the domain of cosecant? That's the range. And this is where I start. Okay. First, think about this. What is cosecant? Cosecant is 1 over sine. So it's going to be all real numbers except anywhere that sine is 0. When will sine be 0? All multiples of pi. Except k pi for all k. K is an integer. What's the domain of secant? Which is just another way of asking, where is cosine equal to 0? Cosine is equal to 0 at all odd multiples of pi over 2. And cotangent, it's the reciprocal of tangent. So it's going to be cosine divided by sine. Again, we're asking somebody. This becomes undefined when sine is equal to 0. And sine is 0 at all multiples of pi. What are the ranges of these? Well, we can go to the range of cotangent real quick. It's the reciprocal of tangent. What's the range of cotangent? Minus infinity to plus infinity, non-inclusive. That just leaves secant and cosecant, which are the tricky ones. Secant and cosecant, what is the range of cosecant? It's going to be greater than 1 and less than negative 1. Or you could write that in set notation as, you could write negative infinity to minus 1 inclusive and plus 1 to plus infinity exclusive. You could write it as 2 separate sets. Or actually, I think to make it proper, you would write that big U, union. We're going to make it proper. A simpler, quicker, shorter way to write the same thing would be the absolute value of y is greater than or equal to 1. Now, if y is minus, or the absolute value of cosecant theta is greater than or equal to 1. So if cosecant of theta is minus 1, then minus 1 squared is still 1, and the square root of 1 is plus 1. Does everybody understand how this absolute value notation for this same thing works? That it's just taking care of this negative sign half of the range. Point is, cosecant can never equal anything between 1 and negative 1. Similarly for the secant. You get the same range for the secant. The only thing that changes are the domains are slightly different because of where their reciprocals go zero. What are some of the things that y'all feel like you need to work on? What are some of the things we've covered in the past few weeks that still aren't quite clicking for you? Beautiful. That's excellent. That's a really good question. What are the key points? Key points of a graph or a function. It's actually the key points of the function that you're looking for in order to draw a graph or to sketch one. What are the key points? Of cosine theta? What are the key points? What's the first one? Say again? Well, let's not get there yet. The very first key point for every one of them is always the origin. Now there's going to be 4 more. There's the period, the full period, which in this case is 2 pi. There's the half period, which in this case is pi. And then there are the 2 quarter period points, which in this case would be pi over 2. Well, let me keep writing everything like I was. And 3 pi over 2. So, for any function that you want the key points for, you want theta equals 0, theta equals the period over 4, theta equals the period over 2, theta equals the period, or 3 times the period over 4, or 3/4 of a period, and theta equals the period total. Those are your 5 key points.
Do you have to write it like that, or can we write it as pi?
The question is, what is the period? Let's use this example. Now, if we're talking, we'll go ahead and finish cosine theta. And yeah, cosine theta, the key points are, call them out to me. Theta equals 0, 2 pi over 4, 2 pi over 2, 6 pi over 4, and 2 pi. So that becomes pi over 2. That's just pi, and that's 3 pi over 2. So you graph that function out. There's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine at 0 is 1. Cosine at pi over 2, 0. Nope, I'm doing that backwards. What's cosine at pi? Minus 1. Cosine at 3 pi over 2? Zero. And cosine at 2 pi is back up to plus 1. Then there's your 5 key points. And now you just try to draw the curve as smoothly as you can. Now, what if we're told to plot y equals minus 3 sine 2x? What are we going to look for first? What do we want to identify first? Amplitude. Sounds like somebody got a paper towel. The amplitude in this case is minus 3. I hope you brought enough for everybody. Okay, the amplitude is minus 3. Now, what's the angular frequency? Two. That's it. The angular frequency, omega, is not the period. What is the period? Two pi over omega, which is 2 pi over 2, which is pi. Now is where you need to remember this instead of the pi over 2. Now, what are the key points? Which is the period divided by 4, the period divided by 2, 3 times the period over 4, and the full period. Now these are our key points. So we're graphing this function. We're going for 0, pi over 4, pi over 2, 3 pi over 4, and pi, 1 period. The problem in the book or on the test may call for you to graph 2 complete periods, or 3 complete periods. This is still your fundamental period. If you need to repeat it for the problem, then just repeat the same thing. Now, we're plotting sine. Sine at 0 is sine at 0 is 0. But we have an amplitude of minus 3. So now, what's the amplitude? The amplitude is negative 3, but sine of 0 is still 0, because negative 3 times 0 is still 0. We go to pi over 4. Sine would be at the first quarter period. What would sine be? The first quarter period, sine would be 1. But we're multiplying it by negative 3. So it goes to negative 3. Pi over 4 minus 3. What's sine at the half period? Back to 0. Pick it up on the pattern. Now sine at 3 pi over 4 would, at the 3/4 period, would be negative 1. But we multiply by a negative 3, and that brings us up to a positive 3. And sine at the whole period is back to 0. Now just draw in your curve as smoothly as you can. What to? Oh.
But how do you get that to pi?
Because the period is not the angular frequency. This number, this coefficient of x, is the angular frequency in the function. The period is 2 pi divided by that omega. And when you divide 2 pi by 2, all you have left is the pi. Everybody see how these key points work? It's always going to be 0, 1, plus 1, minus 1, 0, one way or the other. Then you multiply by the amplitude to get the actual coordinate. You use this coefficient, the omega, to find out the period, and then you just take the fractions of the period to get your key points. The wave function stays the same. Now, what if this had a constant added to it? Well, a plus 2 means this whole graph would just move up 2. So here, where it's minus 4, it would actually be minus 1. Here, it would be back to 2. Here, it would be plus 2 more here. And here, it would be back. And it would do this. It's just a vertical shift, positive or negative. But, and this is one that caught some of you on the homework assignment. What if we were asking for the domain and range of this? What's the domain? All real numbers. What's the range? The amplitude is -3, so the range would be, right. I'm taking it one step at a time. The range, if it were not for this constant, the offset, the range would be -3 to 3, inclusive. But we have an offset. So the range now is actually -3 plus 2 to 3 plus 2, inclusive, or -1 to 5. You see how that works? You bet.
51 is
Y equals 5 minus. Oh, y equals 5 minus 3 sine theta or sine 2x or something. Addition doesn't matter what order you add in. So you can move it around to put it in whatever order makes sense.
I thought it was 5 minus 3, that would give you that's your amplitude.
Ah.
Is that like
Yeah, no, this does not equal say again?
unless you do that?
Unless you put the parentheses there, that doesn't mean that. Do we have any more questions? Everybody got a handle on these key points and how these graphs work? What if we were graphing a tangent function? We're not going to graph it, but let's just what would be the key points of that? What's the amplitude? The angular frequency, omega, is 3. What's the period? Nope. What's the period of tangent? No, just, yeah, it's pi over omega because the period of tangent is not 2 pi. The period of tangent is pi. So the period of this function is not 2 pi over 3, but just pi over 3. Once you do that, you get the key points the same way. Theta equals 0. The period over 4. The period over 2. 3 times the period over 4, and the period, which is 0. Pi over 3 times 4 is 12. Pi over 2 times 3 is 6. Pi is 3 over 4 times 1 over 3. It's divided by 3, it gets canceled, so it's pi over 4. And then just the period, pi over 3. Okay? Make sure I don't confuse you on that one. we're getting 3 times the period divided by 4. The period is pi over 3, so it's 3 times pi over 3. 3/4 times pi over 3, they cancel. It equals pi over 4. And there are your key points. Zero, pi over 12, pi over 6, pi over 4, and pi over 3. What's tangent of 0? Zero. Sine of 0 is 0 divided by cosine of 0 is 1. There's your first point. What's tangent at the what's tangent at the first key point? What would this be if we were doing a full period of tangent, a normal, unmodified tangent function? Would be pi over 4, and that would be tangent at pi over 4. Sine of pi over 4 is square root of 2 over 2. Cosine is square root of 2 over 2. Anything divided by itself is 1. So here, tangent would be 1. What would be tangent at pi over 6, which would actually be, what, pi over 2? If this were an unmodified function, what would pi over 2 be? No? I think I left out a P. It's a silent P, so. That's an asymptote. Pi, tangent would be undefined at that asymptote. Now, if we were doing this normally, instead of having these two over here, we would just have minus pi over 12 here and minus pi over 6 here. And this would be another asymptote. This would be minus 1. And we would go on down like that, and that would be the normal graph of tangent that you see. We did our key points using that, so we're now looking for tangent here at pi over 4. What would tangent here at pi over 4 be at the next key point on the normal function? It would be this negative 1 right here. And here at the full period, it would be back at 0. So the tangent function would do this. Basically, it's this piece moved over here. Now, what happens because we have an amplitude of 4? Doesn't shift. It stretches it. So that's where we would be. Here's minus 1, 2, 3, 4. We'd be down here. And I don't have enough room on the board. But it would be doing that. So it just stretches your graph vertically. It doesn't. Yeah. Now you can shift it by adding a constant. That'll shift it up vertically off of, so instead of being passing through where it would pass through 0, it would be passing through the constant offset, plus or minus. If we had something like, then that means this would be doing this. Got another 15 minutes of review time. So, who has any questions? Any questions from homework or from the... Yes, go ahead. No, go ahead. What were you going to ask?
I was going to ask for help on 12, 14, 16 on page 166.
12, 14, and 16? And you were asking about which one?
It was 56 on 13.
So you're asking for minus 1/2 sine pi over 8x plus 3/2?
Yeah.
Okay, and you're looking for which ones? 12, 14, and 16. Okay. For what numbers x and I want to touch on his because the one you're asking about is literally the same mechanics of doing this. It would just be repeating them with different numbers. So if we have time, we'll do it. But I do want to touch on the one that we haven't looked at yet first. Okay, for what numbers x minus 2 pi less than or equal to x 2 pi. So we're looking for x such that minus 2 pi is less than or equal to x is less than or equal to 2 pi. Which could be written, but this, because I think this might be part of the confusion, is understanding what the problem is saying. This is just another way of writing minus 2 pi to 2 pi inclusive. Now, they're asking for what numbers does the graph of y equals cosecant x have vertical asymptotes? What are they asking for? Where would the vertical asymptote be for cosecant? No. Cosecant is the reciprocal of sine. So anywhere that sine is equal to 0 is where cosecant will have vertical asymptotes, where it becomes undefined. So where does that happen? At 0, pi over 2. Really? Sine at, okay, we're at 0, pi over 2. Yeah. Pi. I do have to draw it for me to be able to picture it. I'm a physicist. I have to draw pictures. Yeah, I think it's 12, isn't it? Oh, okay. Oh, I'm sorry, I am doing the wrong one. We want to know where does cosecant x equal negative 1. Okay, well, we're still... Okay, now we want to know where cosecant x equals negative 1. Am I doing the right one now? That's number 12. Okay, where does 1 over sine of theta, what is the reciprocal of negative 1? It's still negative 1. So, what we're asking about is, where is sine equal to negative 1? Sine at 0 is 0. 0 here, it's minus 1 here at 3 pi over 2. At minus pi over 2. That's it. So, it's at x equals minus pi over 2 and 3 pi over 2. Do you see how we got that?
Yes.
Okay. 14 is asking for where does it have the vertical asymptotes? That means where is sine equal to 0? Well, sine is equal to 0 at 2 pi, at pi, at 0, and at 3 pi over 2. So for number 14, no, yeah, you're right. Sorry. So for number 14, where is cosecant x undefined? Minus 2 pi, minus pi, 0, pi, and 2 pi. It's always important to think about what is the function they're asking you about. In this case, they're talking about cosecant. Where is it? Where is it equal to minus 1? Well, that's where is sine equal to minus 1? Because cosecant is the reciprocal of sine. It's going to have asymptotes. It's going to be undefined anywhere sine is 0. On 16 was the other one you were asking about. It's looking for the cotangent of x. Where does it have vertical asymptotes? Well, again, cotangent is the cosine divided by sine, so that's just another way of saying where is sine equal to 0? It's going to be at the same places. Now, the graph of cosecant x and cotangent do not look anything alike, but their asymptotes are at the same places. Their domains are the same. Now, your question in 5 minutes. For 16, where does it have vertical asymptotes? Cotangent is cosine divided by sine. So it's going to be undefined. It's going to have vertical asymptotes anywhere sine is equal to 0. Say again?
I'll review that one. You don't have to go over it. Everybody's got it. I can figure it out.
For number 56? Oh, you're talking about number 16 there. Okay, yeah.
Yeah, you said it was the same thing. Maybe that's right. I got negative 3 pi over 2 and then negative pi over 2. That would be
Cosecant of x is 1 over sine of x. So cosecant of x is going to be undefined. It's going to have vertical asymptotes. Anytime sine is 0. Cotangent of x is cosine of x divided by sine of x, and it's going to be undefined when sine is equal to 0. This will be undefined. It will have a vertical asymptote. The same place as this will have a vertical asymptote. What that's telling you is that both the cosecant function and the cotangent function have identical domains. Okay? Now, y equals minus a half sine pi over 8x plus 3 halves, and there's absolutely no chance I'm going to remember all of that, so somebody be ready to read it out loud to me. Y equals minus 1/2 sine pi over 8x plus 3 halves. What's the amplitude? Minus 1/2. What is omega?
pi over 8.
What is the period? No. 2 pi divided by pi over 8, which is 2 pi over 1 times 8 over pi, which is 2 times 8 equals 16 is our period. Yep.
That's what I got, so I hope it's right.
Yeah. What are the key points? Okay. And minus a half, minus 1, minus 1.5, minus 2, plus a half, 1, 3 halves, 2, 0, 4, 8, 12, and 16. Sine. Sine at 0 is 0. What is sine at the first key point? Nope.
Oh,
Sine at the first key point. Forget about these numbers. We've got those numbers here. We've already written them down. 4, 8, 12, and 16. At the first key point, sine is plus 1, but it's multiplied by minus 1/2. So there's our first key point. Next key point, sine is back to 0. And I know I'm ignoring the plus 3 halves for right now. We're taking this, we're just doing this first part, then we'll shift it. Okay, next one. Sine would be -1, but multiplied by -1/2, it comes up here and then here. That gives you this graph, which now gets shifted up 3/2. So, get 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And you do it a whole lot neater than that because you wouldn't be as rushed for time as I am. And how would you get the range? The amplitude plus the offset. See y'all Thursday. Okay, thank you. Homework's being turned in. Thank you. Thank you. You certainly can.
So what I'm looking right here, it's looking for the vertical asymptotes of cotangent. And up there you said it was the same as
Cosecant.
cosecant. But so when I graphed it out though, like, I don't know if I just graphed it out wrong, but the vertical asymptotes are falling on the
Pi over 2. Pi. 3 pi over 2.
well, that was different than what was on the board. What was on the board was -2 pi.
Negative pi over 2. Negative. Where is...
So that's where I just want to make sure that was.
Yeah, well, let's look at that carefully. What are they asking?
They want to know basically between -2 pi and 2 pi. They want to know the vertical asymptote
Exactly.
of the cotangent.
And where will cotangent be undefined? No, stop looking at your graphs. Where cotangent is undefined is where sine is equal to 0. Remember? So where sine of theta is equal to 0, cotangent is undefined. Now, it's confusing you because you're getting it confused with cosecant. Look at cosecant. Cosecant of theta will be undefined when sine is 0. So in both cases, everywhere sine is 0, you get an undefined. You get the function undefined. Now,
So is my graph wrong then?
I don't know. Let's look at your graph. That's tangent. No, that's wrong.
Okay. So
That's tangent.
okay, and then
That is not cotangent. That's cotangent shifted.
I thought cotangent was basically the same. It's just on the
No, it's reversed and shifted.
oh, it's reversed and shifted.
Yes.
So then where is it? So how is it shifted?
It's cotangent is 0, where cosine is 0. At minus pi over 2.
Okay.
And at pi over 2.
So it's this. It's just shifted over to.
Yep.
Okay, that's
where you got. That's where you went wrong.
because I was looking at my graph. Okay, thank you.
Uh-huh.